Okay, infinite series. The first infinite series I want to talk about is a geometric series, which is something that we've seen already in grade 11, and it's very easy to analyze for infinite series. So, general term of a geometric sequence looks like this: a r to the power of n minus 1. Okay. A geometric series is characterized by the fact that we have, to get to the next number, we multiply by a common ratio. Okay. So you multiply by r, you get the next one. So as a sigma notation, right, it's typically written as I is equal to 1 to infinity a, right, some a r to the power of n minus 1. Okay, so we already know that if this was going up to n, right, sorry, this should be I. The formula is a r to the power of n minus 1 over r minus 1. Now let me do distribution. So you get a r to the power of n minus a. Okay, split the fraction. A r to the power of n over r minus 1. Okay, r minus 1. Now, if r is actually a big number, so bigger than 1, not even big, just bigger than 1, then every consecutive terms get bigger. So the more you add up, you can't help but for the series to grow. So if this is true, the sigma is going to become infinity. Okay. However, if so actually, to be more precise, r can also be it can also be less than negative 1. This time it's going to add and subtract things, but still it's not going to converge to anything. It's going to diverge too. Okay, let's consider what happens if the r is actually, the absolute value of r is between less than 1, which means r is between 1 and negative 1. So some kind of fraction of values. If you have AR, because it's between negative 1 and 1, AR is going to be smaller than this one, right? And AR squared is going to be smaller than this one, right? It's going to constantly get smaller and smaller and smaller. And if we actually analyze this form here, okay, so a r minus 1. Now r to the power of n, that right there, because of this scenario, is going to approach 0, right? The more you multiply a number that's less than 1 by itself, it's going to approach 0. So for example, 1 over 3 to the power of n. So this entire expression is approaching 0. Okay, so so essentially this here, I is equal to 1, a r I minus 1 to infinity is going to equal to just this, which is a. Let me multiply the negative back under, and you get 1 minus r. So a geometric series with a common ratio that's between negative 1 and 1 will always converge. Okay, it will always converge to a over 1 minus r. So that's the first basic technique to determine if an infinite series is converging.